All right, let's begin. So in the previous lectures, I touched upon what is a finite state machine, what is its formal definition, and so on. So basically, a finite state machine is nothing but a set of states with transitions between them. All right. So these transitions depend on the input symbols. Yeah, silence, please. So suppose you have m states and you have n input symbols. How many transitions will you have? You have m states and you have n input symbols in your alphabet set. Totally, how many transitions? Transitions means arrows. How many outgoing arrows will you have in your state diagram? M into n. Because for each state, you have to account for each input symbol. Where does this particular state from here, where do you go to on this particular input symbol? So for each input state and input symbol, what is the output state? All right. So if you have m states and n input symbols, then you will have, okay, three of you get out. White shirt and the next two guys get out. Get out immediately. Don't waste my time. Yeah, you three only. Yeah, you and next two guys get out quickly. You are bright enough. You can learn outside the class also. Please don't come. So yeah, so if you have m states and n input symbols, you will have m into n transitions or m into n arrows. All right. So for each input symbol, there has to be exactly one arrow, no more, no less. Because we are right now discussing deterministic finite automata. Although I'm not explicitly saying it, but these are deterministic variants. We will look at non-deterministic variant later. Okay. So a finite state machine can be represented in multiple ways, like a state diagram or like a table. I mean, actually, it's a phi tuple within which the most important and the most difficult aspect is the transition function. Okay, so all the others are easy, like set of states here S1, S2, S3 in this example. Input alphabet is A, comma B, and then start state is S1. Set of final states in this example is S2. These are all easy. The difficult thing is only the transition function. For each input state, for each input symbol, where do you go to? So this transition function you can represent either in the table format or a list format. Okay, if you are representing in table format, it should be the state should be listed as rows and the input symbols are listed as columns. So if you are in state S1 and you get input A, then you go to state S1 and so on. Same thing you can represent as a list here. All right. So this is a finite state machine formal definition, and we also looked at some examples. So now look at okay, in the last example, I said that if you want to accept strings which are of the form A star, that is 0 or more A's. So it should accept epsilon, it should accept 1A, 2 A's, 3 A's, and so on. A's, any number of A's. So for it to accept epsilon, the simple thing is you make the start state also an accept state. Okay. So this will always hold true. So whenever you want to accept an empty string, you just make the start state as an accept state. And the reverse is also true. Whenever the start state is an accept state, it will automatically accept empty string. Okay. So let me just mention that. Any finite state machine which has its start state as one of its accept states will accept epsilon, that is empty string, and vice versa. That is, if you want to accept epsilon, blind rule, just make the start state and accept state. That's it. All right. So now let's look at a few more examples. But before that, I'll just revisit, one example. Say, suppose you want to accept a language or recognize a language of the form A, B plus. What does it mean? 1A followed by one or more Bs. Okay. So it should accept strings of this form A, B, A, B, B, A, B, 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 and so on. So here, you have 4 states, of which one is a dead state, and the 3 states have some meaning. So again, always keep this thing in mind. Every state, it's not just a number S1, S2, S3. No, every state has a meaning. If you are in a particular state, you will know what portion of the string you have seen so far, you have read so far. So the state number or whatever, it captures that information. So that information is sort of stored in the state. So if you are in that particular state, it means you have read this portion of the symbol. That's it. That's what the state means. So for this particular example, like A, B plus, what does it mean? 1A should be followed by one or more Bs. Okay. So now this can be divided into 3 parts. One is you haven't read any symbol yet. Okay. So that is the start state. The moment you read at least one A, okay, now you go to the next state. It means you have read at least one A. You have seen at least one A. In S1, you haven't seen any symbol, be it A or B or whatever. But if you have seen at least one A, you go to S2. So if you are in S2, it means you have seen one A. That's what the meaning of S2 is. All right. And now the next step is you should see at least one B. All right. But if you are in S2, it's not like you have seen a B. You have only seen one A. That's what S2 means. If you see a B, now you go to S3. You should change the state. You should go to S3. And S3 means you have seen one A followed by at least one B. All right. Now, if you see any more Bs, do you need to change the state? No, because one or more Bs is all the same thing for this particular machine. So whether I see 1B or 2Bs or 10 Bs, I will still be in the same state because all these are same to me. All that matters to me is I should have seen 1A and then 1B. After that, any more Bs I see, it doesn't make a difference. I will still remain in the same state. Okay. So in S3, you have a loop on B. Because once you have seen an A and a B, now any more Bs you see, all of them will also be accepted. Right? So you need not change the state. So B plus means not one B, one or more Bs. So the moment you see one B, you are in S3, it means you have seen an A, you have seen a B. One or more Bs is same as one B. So you just have a loop on S3. Okay. Now, in any of these states, if you see any unexpected symbol, like if you are in S1, if you see an A, you should proceed. But if you see a B, you reject. So go to dead state. Because you should not start with a B. You should start with at least one A. But you didn't even see an A. You saw 0 symbols and then immediately you saw a B. No, this string cannot be accepted. So go to the dead state. All right. Or you saw an A and now you should see only one A. If you see more than one A, again go to the dead state. So you are in S2, which means you have seen one A. If you see one more A, you should reject it. So you should go to dead state. But if you see a B, yes, you should go to S3. You can go to the accept state. Okay. So every state, whichever state you are in, that state tells you the information of the portion of the string you have seen so far. If I'm in S2, I know I have seen 1A. If I'm in S3, I know I have seen 1A and at least 1B. Why I'm saying at least 1B? In the first step, it is 1A and only 1B. But when you are looping again and again, you would have seen some 2Bs, 10Bs, 100Bs. Even then you are in S3. Now you don't know whether you reached S3 now or a while back. So all that you know is you are in S3. So you know you have seen 1A and at least 1B. Okay. I hope you are getting my point. So it captures the history of the string you have seen, but not to the minute detail. In S3, it tells you have seen 1A and one or more Bs. How many more Bs? It will not tell you. One or more, that's it. Exact count, it will not tell you. Okay, so that much information you need. Whatever information you need, just store that much. You don't need to know the exact count of Bs that you have seen. It doesn't matter. You should know one or more Bs. Suppose if I say two or more Bs, then I will have S4 from S2, where I saw 1A. I will read 1B, I will go to S3. I should read two or more Bs. So I will have an extra state. I will read one more B and go to S4. Now in S4, I know I have read two Bs. I can read more Bs, so I'll have a loop on S4 for B. Okay, anyway, the more examples we work out, you will get a better clarity. So let's try one more example. So build a machine which accepts the language A star B. Okay. So A star B means 0 or more A's followed by 1 B. All right. So it will accept strings like B, AB, AAB, triple AB, and so on. Okay. All right. Yeah, this guy with the laptop. Yeah, you tell me the answer. What are you doing? What are you doing with the laptop then? So tell me whatever you thought. It need not be the right answer, but what is your thought process? Tell me that. What is the language I asked for? How do you describe this language? What were you doing then? Yeah, the girl next to you. Can you tell me? See, why do you guys sit in class, please? I don't understand. Either you know everything or you know nothing. I thought you knew everything. Now I know that you know nothing. Why do you sit in class when you don't want to listen? Just for attendance. See, it doesn't hurt me. This attitude hurts only you. The only business of a student is to gain knowledge. That's it. You are not supposed to be doing any other business other than that. And the business of gaining knowledge should be independent of any utility. Knowledge itself is your utility. Whether that knowledge is applicable somewhere, not applicable somewhere, whether it will bring you a job, not bring you a job, whether it will satisfy you, no, none of these things. Basic curiosity for knowledge is the basic criteria for being a student. If you don't have that basic curiosity, you don't deserve to be a student at all. That's all I can say. I'm not here to give you moral lectures and to sort of babysit you. It's up to you. Whatever you want to learn, you learn. Whatever you want to take, you take. But it's just a suggestion. You are wasting your time, and if you disturb my time as well, and your parents' money. That's all I can say. Okay. Who else? Okay, that girl with specs, pink dress. Yeah, yeah. Did you do it? How many states does this machine have? Okay, so 3 states, S1, S2, and then S dead. So I'm calling it SD. All right. S1 is a start state. What is the final state? S2. Okay. What are the transitions? S1 to S2. It goes to S1 to S2 on what symbol? What is the symbol? B. All right. Then S1 goes to SD on A. Then S2 with S2 to SD. Loop. Loop on A. Okay. S2 to SD on B. That's it. And there should be SD loop on A comma B. Is this right? No? Yeah, the girl next to you. You tell me. What is wrong in this? S2 to SD. What should it be? AB. But there is already an A here. You can't have two outgoing arrows for the same symbol. If I write AB here, it means S2 goes to S2 on A and S2 also goes to SD on A. That is not allowed. Okay. Last row, check shirt, black and white. Yeah. Yeah. You tell me. What is the mistake in this? Loudly. I can't hear you at all. Be a bit loud. On SD, A comma B will not have self loop. Okay. All right. So maybe you were in dead sleep that you don't know what a dead state is. This is a mistake you found. Okay. What else? Okay. Okay, the first girl. Yeah. Yeah. What is the mistake in this? Is there a mistake? What is the mistake? Why did you say yes? because I already asked what is the mistake. Then you're saying we should have one more state. Okay. So let me draw it with a say different color. So suppose I have S3. Okay, now S2 with S3 on B. Okay. S3 to SD. All right. That's it. So what does this achieve? Why did you have to add this state? So what is S3 doing, which SD is not doing already? Because once you go to S3, there is no way in which you come back to S2 or S1. That is the same thing when you are going to SD as well. So S3 is playing the same role as SD, right? So why do you need an additional state? Right? So that is not the mistake. What else? Who wants to answer? Sorry, can you tell me again? S1 to S2 should be A and S1 to SD should be B. But what about B, AB, AAB? Where is B here? It's going to the dead state, right? Yeah. So there will be a self loop on S1 for A, then S1 to S2 B. Remove the self loop on S2. Sorry? S1 is also an accept state. If S1 is an accept state, then it should accept epsilon, right? No, what you're saying, if S1 is an accept state, it should accept epsilon. But epsilon is not supposed to be accepted. The language does not have epsilon. I can't understand. Yeah, silence, please. What? We have B as input and then see whatever the remaining arrows are, it does not matter. If the start state is an accept state, you should accept epsilon. This language does not have epsilon, so start state cannot be accept state. That's all. So what about S2 on A? Where does it go to? Dead state. That's it. S1 to SD. It's there, no B. Sorry, it shouldn't be there. I'm sorry. This is okay? This is the answer. You see, again, try to think semantically about the states. A star B means 0 or more A's followed by 1B. Okay. Now, there is no distinction between 0 A's, 1A, 10 A's, 100 A's, no distinction. All right. So, when you are in S1, you haven't seen any symbol. So, 0 A's you have seen. Even if you see 1A, there should be no difference. Even if you see 10 A's, there should be no difference. So, you just remain in S1. It is not changing the state. What matters is whether you have seen a B or not. You have seen no B's or you have seen one B. So S1 means you have seen no B's. S2 means you have seen one B. Okay. So As long as you are not seeing a B, it does not matter what other symbols you are seeing. Whether you are seeing an A or you're not seeing an A or you're seeing 10 A's, does not matter. You are still in S1 because you have not seen a B. That's it. So for all the other symbols, you just loop on to S1. You just stay in S1. So you haven't seen an A, you have seen 10 A's, you have seen 100 A's. You are still in S1 because you haven't seen a B. That's it. The moment you see a B, you change the state. You go to S2. That's it. So once you are in S2, all you know is either you have seen 0 or more A's and 1 B. That's it. And S2 is an accept state. This is all we need. Any other unexpected symbol in any of these states, you go to the dead state. In S1, as long as you keep getting A's, it still means you haven't seen a B, so you still remain in S1. That is acceptable. You can keep getting A's. It is acceptable until you get a B. The moment you get a B, you go to S2. And you should not see any more symbols in S2 after B. B should be only one. The last symbol should be 1B. If you see any more A's or B's, that string should not be accepted. So you go to the dead state. Okay. So try to give meanings to the states. S1 means you haven't seen a B. Fine. Can you see an A? Okay. It's also okay if you don't see an A. It's okay if you see an A. So you just have a self loop. It will anyway account for 0 or more A's. So self loop on S1, it means you haven't seen a B, you have seen 0 or more A's. And the moment you see 1B, you go to S2. If you see any more B's, you should not accept it because there should only be 1B. So if you are in S2, it means you have already seen 1B. If you see any more B's, go to dead state. If you see any more A's, again you should go to dead state because it should end with a B. Nothing more should come after that. That's it. Okay. So that is the thing. Okay. All right. So now quickly work out next example. Yeah. Now let's modify it slightly. Build an FSM that accepts language A plus B. That is 1 or more A's followed by 1B, like AB, AAB, triple AB, and so on. So here, how many different scenarios you need to cover broadly? In the previous case, broadly 2 scenarios. I haven't seen a B, I have seen a B. So 2 states. Dead state, leave it aside. But broadly 2 states. Okay. In this case, how many such scenarios you need to cover? 3. What are the 3 scenarios? What is the first scenario? Seen an A. Okay. What is the second scenario? You have seen a B. What is the third scenario? Not seen a? That is covered in the first scenario. You have seen an A means you have seen an A and not a B. Exactly. So there are 3 scenarios. The first scenario is not seen an A. The first scenario is you haven't seen an A. You haven't seen an A. That is the first scenario. Now you have seen at least one A, go to the second state. That is a different scenario. In the previous case, 0 or more A's are all in the same scenario. It's not necessary that you should see at least one A, but here you should make a distinction between no A's and one A. So first scenario here is you haven't seen any A's. Second scenario is you have seen at least one A. Now within this, there is no distinction between 1A, 2A's, 10A's. So you have seen 1A. Now any more A's you see, you will not change the state. So on the second state, you have a loop on A. Because scenario is not changing. At least 1A is the scenario. So the moment you go to S2, you have seen 1A. Now any more A's you see, it will still not change the fact that you have seen at least 1A. So you have a loop on S2. And then next scenario is you have seen a B. Go to S3. That's it. The remaining, whatever arrows are missing, mark them to S date. Okay. So try to think, try to imagine how many scenarios I need to break it into, how many states I need to break it into. Then you will get an idea what states you have and what transitions you need. Okay. So I have 4 states, S1, S2, S3, and S state. So first one is the start state. Here, if I'm in S1, I know I haven't seen any symbol so far. Okay. And the next scenario is I have seen 1A. So on seeing an A, I go to S2. In S2, all that is important to me is I should have seen at least 1A. Okay. So I have seen an A. If I see any more A's also, it will not change the fact that I have seen at least 1A. So I need not change the state. I can remain in the same state. So I will just have a loop on A. So it will still uphold the fact that I have seen at least 1A. And S2 also means I haven't seen a B so far. The moment I see a B, I go to S3. Now S3 is not about I should see at least one B. S3 means I should see only one B. If I see any more B's, I should go to dead state. Okay. So in S3, if I see a B or any more, I should not even see an A after B. So if I see an A or B, I should go to dead state. S3 is the accept state. You see, you should not forget marking the accept states. Your entire machine may be right. But if you forget putting the accept state, it means this machine will not accept any string. Right? So it's a very important thing. You may, suppose if this question is given in the exam and if you don't put an accept state, you will lose marks because you cannot come to us and say this is the same machine. No, it's not the same machine. The machine with accept state will accept these strings. Machine without any accept state will accept no string. Okay. So it's very important that you mark the accept states as well. Okay. Now all the remaining arrows, you just mark them to dead state. If you are in S1 and if you see a B, you should go to dead state because the starting cannot be B. You should see at least one A. So you should go to dead state on seeing a B. And S2, nothing. You have accounted for A, you have accounted for B, and S3, you have accounted for AB. That's it. Okay. So try to think meaningfully. Another best way of thinking meaningfully about states is, so you can think, okay, instead of naming it S1, name it as say S0, which means I haven't seen any symbol so far. And here instead of naming it S2, name it as SA plus, which means I have seen at least one A. Okay. And here instead of naming it S3, name it SA plus B, which means I know I have seen at least one A or one or more A's followed by one B. That's it. So if you try to name your states like this, the moment you know you are in SA plus, it means you have seen at least one A. So that's what the state is telling you. Okay. All right. Now quickly build the machine for this A plus. That is one or more A's. Here the language is still AB, but you are accepting only strings with one or more A's. Here broadly, how many scenarios will you have? 2. What is the first scenario? You haven't seen even one A. Second scenario is you have seen one or more A's. That's it. And a dead state. So basically 3 states. Actually, it is nothing but the previous machine. You just remove this part and you directly have arrows from SA plus to the dead state. So you have S1, S2, S1, you haven't seen any A. Fine. If you have seen even a single A, you go to S2. S2 is anyway the accept state. You have seen an A and you came to S2. And if you see any more A's, you still remain in S2. Because S2 is about seeing one or more A's. All right. But if you see a B, you should reject it. So go to the dead state. And if you see a B in the beginning also, you just go to the dead state. And in the dead state, you should have a loop on A comma B. Even here, there should be a loop. Okay. That's it. Simple. All right. Now, last example. A star, B star. That is 0 or more A's followed by 0 or more B's. So what kind of strings does it accept? What is the first string that it will accept? Empty string or epsilon. Then A. Then B. Then if you go in shortlex order, first all the strings of length 0, there is only one string epsilon. Then strings of length 1, A and B. Strings of length 2. First string in this is AA. A star, B star, any number of A's. So AA, then AB, then BA. It will not accept BA because order should not change. It will accept BB. And strings of length 3, AAA, then AAB, then ABB, then BBB. Yes. There can be more than one accept state. There can be 0 accept states. So there is no limit on the number of accept states. 0, 1 or more, any number of accept states you want, you can have. Start state should only be 1. If there is no accept state at all, it means that machine does not accept any language or any string. So here broadly, how many scenarios we have? 4. Okay, what are the 4? Okay. 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 You should account for more, one or more, or 0 or more A's, 0 or more B's. I mean, yeah, it can be extended along those lines. Yeah. 5 scenarios. What are they? Nothing. Okay. All A's. All B's. A's followed by B's. Okay. A's followed by B's followed by something else. Ah, that is the dead state. Something else is like different from B. Yeah, that is the dead state. That's fine. So that's fine. Sorry? Including dead state will be 5. Excluding dead state will be 2. Okay. Yeah. All right. So you tell me the states. How many states does this machine have? 3. What are they? S1, S2, and S dead. Okay. Yeah. S1 and S2 are final states. Okay. Okay. There is a self loop on S1 on for A. Yeah. S1 goes to S2 encounters a B. Okay. S1 to S2 on B. Self loop for B. Right. Self loop for B. A takes S2 to SD. A. Okay. A takes S2 to SD. And then a self loop of AB on. That's it. Yes. Is it right? Yeah, it's correct. Yeah. So although you sort of have 4 scenarios, but one can sort of reduce them to 2 or 3, including the dead state. So the idea is, first, you haven't seen any symbol. Okay. So that is S1. Or actually you have seen 0 or more A's. That is S1. Fine. Now, since S1 is also a final state, it will anyway accept epsilon. Okay. Now, the only thing is, you cannot have both A and B self loop on S1, because if you have a self loop on S1 for both A and B, what will happen? Suppose I give this kind of a machine. I will say this is the final state, this is the start state, and there is a self loop for both A and B. Is this not covering A star, B star? It'll accept AB as an input eventually. Exactly. The order is not upheld here. So it will accept A's and B's in any order. It will accept BAB, ABB, whatever it is. So the order should be maintained. For that, you have to have a separate state the moment you see B. All right. So that is why, although A star, B star, although S1 sort of tells you that you haven't seen any A's or any B's, it is not just about not seeing any A's or any B's. It is about first not seeing any A's, and the moment you see a B, you should go to S2, because order should be maintained. Okay. So once you see a B, you go to S2, and that's it. Now, if you keep seeing B's, you accept it. If you see an A, you reject it. Okay. So you can have more than one final state. You can have none. You can have one. It can be any number of final states. Start state is always 1, but final states can be 0 or 1 or many. All right. Okay. Oh, time is running out. Anyway, let's quickly move on to the next definition, that is language recognized by machine M. So if you see the pattern in which I'm going, I'm first covering some examples and then definition. I'm covering some examples and then definition. In the beginning, I covered some examples of finite state machines, and then I gave you the formal definition of what a finite state machine is. Later, I covered examples of what language is recognized by a finite state machine, like all these previous examples. Is it A star, B star, or A plus B, or A star? Each one of these are languages. A star, B star is not one string. It is a language of different kinds of strings. Epsilon, A, AB, all these are strings which are accepted by a machine. All these strings can be represented using a regular expression called A star, B star. We will get into regular expressions properly later, but I have already given you some examples of regular expressions. But the idea is, what is the language recognized by a machine? I gave you some examples. Now we will formally define it. When do we say a language is said to be recognized by a machine? Okay. So for an FSM, M equal to the 5 tuple Q sigma delta Q naught and F. The language recognized by it is defined as L of M equal to A, where A is the set of all those omegas, where omega is accepted by M. Omega means string. So A is the set of all those strings which are accepted by the machine M. So we are formally defining a language recognized by a particular machine as the set of all the strings accepted by that particular machine. Okay, so now the next question will be, when do you say a string is accepted by a machine? We need to formally define that. Some strings are accepted, some strings are not accepted. When do we say a string is said to be accepted? Intuitively, we know when you are reading a string, by the time you finish reading the last symbol, if you end up in a accept state, that string is said to be accepted by the machine. If you don't land up in an accept state, by the time you finish reading the string, that string is not accepted by the machine. That same thing we sort of define formally. So a string omega equal to omega 1, omega 2, omega 3 and so on up to omega n, where each omega I belongs to sigma. So such a string omega is accepted by a machine with states R0, R1, R2 and so on up to Rn, under the following three conditions. So what are the three conditions? R0 is the start state. Delta of Ri, comma omega I plus 1 is equal to Ri plus 1 for 0 less than or equal to I less than or equal to n minus 1. And finally, Rn belongs to F. So here R0, R1, R2, they are not necessarily different states in the machine. They are just the states in the path of visiting the string. Like you can repeat some of the states in your machine as you visit the symbols in the string. Okay. So R0, R1, etc. they may map onto the same state in the machine. So it's not necessary that there should be n plus 1 different states. We will see. We'll take an example and we will see this later. Okay. So basically, this is a formal definition of how and when a string is said to be accepted by a machine. Okay. The string is made up of n symbols. Then you should visit n plus 1 states, starting with 0th state up to Rn. You should visit n plus 1 states. You may repeat some of the states in the machine already. Okay. In such a way that there should be a pattern. It should be well defined. The function should tell you if you are in this state and if you see this symbol, you should go to that state. This process should be followed. And if you follow this process, at the end, whatever state you end up in, which is Rn, if it belongs to the set of final states, then the string is said to be accepted. Okay. So we'll see the example in the next class. So let's stop here.